This shout out's going to have to go to two girls. Now, a few people said it, but I just saw two girls' timeline, and you guys might have said it before her, a couple of people, but I just, the way Google hands it to me. So I apologize if you think you deserve the credit before her, and so you get the double A. Here's the thing, though. I had to approve her comment, so everybody who I have to approve the comment who gave this, you all get it at the same time because you didn't cheat off of each other's paper, if you will. So critical girl, tributary area, I think was put out in public. I don't think they blocked it for some reason, but quite a few of you said it also over here. So you get the double A also. I think critical girl's from England. I misspelled Shiki. This is my second video on this. She corrected me. And I basically gave her double A. And because I'm a perv teacher, you get a kiss on the cheek. I'm confused. You are from UK. That would make me a cheeky bastard. Anyway, not counting Gregory, of course. Gregory, you don't count. You said this. You knew where I was hinting about this a long time ago. Gregory's a structural engineer from South Africa. He's on Twitter there. You guys can look him up under Ask Gregory. He doesn't count, obviously. But Gregory, wait a minute, wrong one. Gregory sent over this to me in a reply. Area within the critical perimeter and punch shearing, and how the floors are considered, the foundation should be considered as a slab. So I want you to think about that also. And they stopped that with the big piers and pressure-induced forms, piles, etc., or driven piles combination, just so they don't go anywhere. But they also can punch through, and that's why you see that huge slab at the bottom, 4th floor, 3 foot thick or whatever. All right, let's move over to, why do I have this open? Oh, so you can find this called Structure Points Concrete Software Solutions, and this will talk about shear strength of concrete slabs with openings. That's with the openings there. They're referencing these really, but you'll see some reinforcement on that. All right, let me move over a tab. So critical shear perimeter. I want you to look this up. I'll give you a quick little detail. This should be a shorter video. This was the profile of it, how you would get there from here. So if I could chop this away and let this fall away, and chop this and let this fall away, and just had this deck from here to here, I'd have like an overhang deck, right, from this column, so the steel would be near the top. Well, wait a minute, so let's slop this and dump this away to the left. And now we're looking at an overhang here and on this side. The steel is near the top. That's awesome. That's the right place. We want it at the bottom if it's in the middle span, so there it would be there. I'll go over this in a longer video, more details in longer videos. Oh, incidentally, I had a troll engineer. At least it says structural engineer, and I did track it. It does look like a structural engineer from England. He said that he didn't attack my content. He attacked me. He says you need to go back to school for 5 years. So for some reason, I got to go back to the current schooling for 5 years. So that means I'm going to come back by the time I'm done 5 years of schooling per his instructions. I will now come back not understanding genders. I will also know how to get a PE with not having to work for it. I will just have to go to classes to learn the test, like a driver's ed class, and they'll just teach me how to pass the test. I will not really know how to do structural engineering. I will learn how to pass the test. So I'm kind of weirded out by that. And the further proof, looking at his background there, I'll leave it at that, is that I see how proud you are of your race car setup inside your room. When I say race car, I mean gaming. He watches the game. You sit on the couch. He's got the foot pedals and the steering wheel and a TV. And he's proud of it, publishing that, saying this. And so I look for structural engineering stuff. I see nothing. I see nothing besides his channel that says that, his site says, oh, we do this and that. We do, all this stuff in England. And yet at your house, you have so much time to play games. Not me. This is my game. All right. I don't play the games. This is the game. This is real life stuff here. So you dabble, and you keep dabbling, and I find you lacking. And I don't know what's the English term for cock nibbler, but maybe that's your term there too. All right. So model precast concrete beams and construction cyclic inelastic loading. This is what NIST did a long time ago. I pointed you guys in this direction many times. You could look up this paper, and this will tell you about cycling of concrete. What you're really talking about is behavior of concrete. I'm sorry. I had a choice. I had 5 years, or guess what? He's so dumb, all I had to do was read a book. So he gave me 5 years of schooling, or I have to read a book. And wow, that's amazing. So I get to do that. And then I'm qualified by his standards. Building code requirements. This would be your concrete guidelines for ACI on this. You can look this up. You can go down that rabbit hole if you want. Obviously ACI's been around. ACI's been around for this. ACI approved this. So it failed. ACI approves a lot of things in techniques that fail. Oh, and that guy from England, he does value engineering. That's the same thing. It almost is saying that we'll lower our factors down so you can get the save dollars. So safety will not be, since I didn't name his name. Yeah, I didn't name his name, so I can say what I want to say. Safety doesn't appear to be his primary concern, but how to save money for the clients. All right, let's look at this page 162 real quickly and talk about tributary areas again. So let's grab a couple of these boxes. So screenshot. So we're at the lobby floor level plan. Let's drag this down. Let's grab a box. So let's grab the full page so you guys can come back to it yourself. Yes, the jacuzzi is not there in this drawing. Get over it. Make a few of these boxes. Let me make at least 6 of them. I know I can copy this. Is just fast enough for me. Let's delete that one. I want them all to be the same size. Great. Really? There we go. So let's put them over top of these areas here. And I say pretend because I have to work on intent. So pretending is the word I'm going to use. Let's pretend that the intent of the critical, let's go back over to that one. The critical area shear perimeter is here. Let's just say that it's actually that they intended it to be right where we're looking at these numbers, where we see 19 number 5s and 16 number 4s. 5s here. 19 5s and 16 5s, this direction. Now, I'm working on a model for you. But let's first go down the line of where I trolled somebody some time ago about I don't understand his placement of the steel here. He has 16 4s here, 16 4s here, and then 14 4s here. How does that work? And someone said, basically, you dumbass, not knowing that I troll, and I troll the ones that think they're so damn smart, specifically some engineers. So I'd rather you just not try to be smart and just give me the damn answer. Don't be smart. Gregory doesn't get smart with me when he gives me the answer. He just gives me the answer. Thank you, Gregory. I appreciate that. So, but some of you guys want to say, you dumbass, go back to school, read a book. So I get 5 years of schooling or I read a book. I'm like, awesome. And he didn't recommend a book. I'm like, damn it. I could have saved 5 years of schooling if you just gave me a damn book. So I'm being facetious. So here's this line, and I'm going to grab it. The spacing is the same. Look at the center line of the column of the boxes here. Great. So the center line is the same on these boxes. Wait a minute. There is no damn box across from this one. Great. So if we have the zone, I know what I'm doing. You know the way I talk, guys. Oh boy. So you know the way I talk. So I'm not really disappointed. I just pretend like I'm disappointed to prove a point. Alright, so I got to make another critical area here, and then another one here between these two. Now this is the critical zone area, right? Critical punch shear zone area, right here and here. Let's go all the way around because there's a parking deck there. Over here, though, this is interesting. This is a step up. This is a step up in decking. So over here, since it's a step up, it was supposed to be a 1 foot step up. It would terminate at the edge there like that. It wouldn't go into this side because this side would then get the critical zone area mounted to the face of it at the beam. Now this is a BMA, so we're going to say it's sitting on top of there. So actually, that would get its own little mini one. And if this is even with the top of the deck, it would get one too. And there's a chance it could be even with the top of the deck, which makes them both integral to each other. Hey, that would actually make it out here, wouldn't it? And they have that one. Well, that's awesome. All right. So I just wanted to let you see that. Wait a minute. I have the pictures up still. Let's see if I have the photographs up. Oh, if you see a face in the background, that means I still have to comment to you. It doesn't mean I'm looking at your channel like that. It means I still have a comment that I have to get to you, like Elaine or Ryan's one. Two girls. I guess we're not finished our banter, so I guess I'll come back to you. You're up one. You're up by one. I think if I couldn't find you. Oh, there it is. I pulled it up. I had to pull it up again because you commented back. So I'll delete that one because you only need one tab open. That means I got to come back and do a score. I need a score too. So anyway, where is it? I'm looking at the underside, and Ms. Tweet gets a comment back. All right, so now you see if you see a face, don't think I'm looking at your channel. It reminds me that I got to come back to the data like these. Remind me to come back to teach you about this stuff, columns, etc. Where the hell is it? All right. So someone said that they don't think that this is over column L. So here's L here. And as we look at it, they're to the right of L as we look at it. So we go to L. I'm going to pull this up and then pull up the L behind us. Just so let's go over that. So I do go over some of your contrary statements to what I may say, and I might have to correct it. So then I pull this down, and I might have pulled that too far. And here's L. Next to that is K, and here's M. They said they think it's M. So M is to the left. So here's L. There's my mouse. I won't move my mouse. I'll just scroll down. Passing columns. It's passing columns. And right about here to the left of L, as we look down at it, we look in this direction, I would say that they're over top of that column. So no, I don't think they're punching into nowhere, hammering into nowhere. Maybe they are hammering into nowhere, but they'll be the winner if they hammer this, if they free this up. They'll be the winner of the elevator ride down, because they'll have created a puncture in the critical zone over here, and they'll get to fall through. The deck around them will fall away. If this is a column and they manage to, with this load on it, if they manage to weaken it enough, the deck will go boom. It will drop down. And when they do that, there'll be a lot of heads going forward, face first, on this column there. So if it is a column, it looks like it's about there. So let's pull this back up. It's going to be a shorter video. I just want to get to you tributary zones and the critical area, critical shear. Let me get Gregory's up. Let's pull Gregory's up. That's a big conversation. Shear links and all that. Gregory is nope. Gregory's here, and this is what I sort of drew the other day when I was showing you the protection. But you see this shape here? That's the shape of the failure that we talk about. If they had shear links in here, that would help hold this together so it doesn't break apart. There are no shear links, and we'll talk about shear links. And well, you guys can look up shear links, but it's basically a bolted connection from the top to the bottom. So if this is trying to break free, it's a bolted connection added with the steel internal. That's the short version of it. Someone sent me a link. I did see your link on the bungee. The bungee would help show how it reacts, behaves. But I want to show how it would not react if it could move, because they do not open up like that. It was a very small fracture would be your indicators. So let's just go with the critical. So now I want you guys to come here and just make your critical zones up, right? Your critical zones. You just throw them in here everywhere above your peers, above your people you think are peers with you. No, I'm just teasing. And make them kind of even there, right? You can make them kind of even. Is this the critical zone area? Is this the area that they actually are calling for 16 number 5s in this direction and 18 number 5s? These are the structural plans. Correction, these are architectural plans. Let's confirm that. These are the architectural, not structural. Let me move that out of the way for a second. So what does that say there? I just want you to understand what you're looking at. And you know I love to make mistakes like that on purpose, so you'll catch on. So some of you are catching on. I think Jamie definitely catches on. A company called me Columbo. That's right. Oh, just one more thing. So yes, I do take on that personality where I purposely make a mistake so it's more stands out more. What is this? Let's say right there. 55. Oh, 65. 65. 55. Or is that an S? Okay, S stands for structural plans. So we have over here in the structural plans, we have a beam. Who removed the beam from the structural plans dated? This is 79, I believe. And then we have one in 80. Who the hell removed them? August, I think it was, roughly thereabouts. Who removed all these BMAs? This is a BMA. This one I would clearly like to know the intent of this. Was this a lateral shear BMA to stop that the deck from shifting in that direction? Was this a lateral shear? Was it designed to take the loading of a plant? I doubt it. Over here, I doubt it was taking the plants are back here. This seems like it's some type of lateral shearing brace that they put in there. Remember what BMAs look like? We went over that in the video. I would love to show it to you, but it looks like that was one of the tabs I trashed. I'm looking above in my tabs. Looks like one of the tabs I trashed. Well, yeah, when I was closing out tabs a minute ago. So now let's talk about my other troll I made where I said I don't get it. So I play dumb like Columbo does. I don't get it. This says 16 fours. This says 16 fours. Now they switch to 14 fours. I don't get this. Well, how to do that? How do you measure that? From here over or from there? And when somebody fell for it and said, it's from the center, you dumbass. You measure from they're equally divided. And so equally divided. Great. So there's the equal divided line. Let's just grab this line and shift it over. Yep, it meets in that box. It meets in the box. So, okay, equally divided. Oh, wait a minute. Let's go to this one first. Equally divided. Okay, so they're equally divided. So let's call it 10 feet. So I divide 14 by 10. I come up with one number. And since these are equally divided, I divide 16 by 10 and come up with a different number. Now all of a sudden, I don't have my rebar lapping. They're not lapping. They're next to each other, but they're not lapping. So that doesn't work for me. So is it, if I knew the numbers from here to here, say that there, right? So we go here. Is it equally divided between here and then left over? So what is the dimensions of this? Is it really to scale? Is the 14 number 4s, are they divided between here and here? You see how short that is, incidentally. So let's move that up. So let's use the outer box. and the outer box. So that's the outer box. And let's move this over. Well, look at the box shift. The box shifts down. So let's use the outer box here. Sounds like one of the things I'm selling. This outer box here is, well, just about equal with that outer box. But this so this would be equally divided here, coming there. But this one, it doesn't even show a zone. It just mounts there. Well, why would it do that? It's not a BMA. BMAs are marked off. Are they not marked off? Well, there is a BMA over here. We saw it rip apart over here. All right, let's get rid of these now. Let me delete that one. And you can see that if I go here, my zone doesn't go over there. So let's look at the rebar reinforcement. It stops here. It's a smaller section. It does not go over. It has 19 number 5s going in this capacity. So it's 1/8 of an inch larger. And they go all the way, they go across. But they appear only to be inside the critical zone. Except they don't. They appear to go out the critical zone. Let's move these out of the way. Well, hell, so does the 16 number 5s. They appear to be going out of the critical zone. So they appear the tributary zone and the critical shear zone, right? Your critical area, your critical perimeter area, interlock with those horns. Those horns we saw, the little horns that come up, they appear to interlock. That, in other words, we should see steel come all the way across 19 number 5s, spaced equally, however that equal thing is, and going this way. 16 number 5s going this way up to, well, this person told me I center line it from here. So I would divide 21 by 1/2 inch from there to there. And from this one, well, where do I stop? Do I stop here? Or do I just go all the way across the deck? Well, obviously, I'll run across some 10 number 4s. This is where it gets kind of crazy. So I'll stop center line here. So I actually have 16 number 5s from the wall going this. Well, wait a minute. There's 14 number 4s here. Okay, so then I run 14 number 4s from here back to the wall. Let me move this up a little bit. Oh, wait a minute. Not quite. I run 14 number 4s back to the wall over to here. And then I run 8 number 5s back to the wall this way. And then I run these J hooks out of the wall. 12 inch on center, number 5s over to here, I guess. But wait a minute, there's the 19 5s. Where the hell am I where the hell are these? We need the shop drawings. So if the police are looking for this, you need the shop drawings. But they already destroyed the evidence. And NIST already just trashed it all. We saw them throwing rebar away. So you're not going to be taking anybody to jail because NIST threw that stuff away. We all know that. And nobody's, unless that engineer is stupid enough to plea bargain, that's craziness. If anything, you want to subpoena his records to see what information he had on the layout. If he has the layout of this rebar there through sounding and testing, oh, now you can get him. You can jam up that engineer if you want to. But you need his records. And self-incrimination, I don't know if those records, unless he gave it to the minister, unless he gave it to this plans people, then you might be able to get it from the building department might be able to have it. The building department, did they ask for his reinforcement schedule? Did he show this, or is he saying, as he states, this is what it shows as a known from the original design? But the thing is, how is it a known? Because we know that over here we've got a crack that has no expansion joint in it. So there is no known here, and in fact, I don't even see where they say put expansion joint over here. Yet an expansion joint was done here, control joint rather, was done here, right about here. And yet we don't see that. Let's see if we can get that in an image. That's out of the image. It's over here to the left. Right here. We don't see that. We don't see that here. So now, all right, so now we have your critical zones. Now I want you to somehow figure out how the hell did they put this rebar in here, right? How the hell did they put it in there? You can count up, you can put the 21 number fours in here, and then you can figure out how do they space. How do they space? Keep in mind you're going to have to let them interact with the rest. So this would be 21 half-inch rebar, so you can come all the way down here like this. Now you got the cross steel coming this direction, which would be 19 number fives. So I don't know how far they go over, but let's say they go, well, there's an arrow, actually. So 19 number fives, 5/8 rebar. Now, let's just, so you just see that they just missed a critical zone on here. Let's do that. Let's be fair. So let's move it over to here. This is 18 number fives right here. It says it right here. Right there it says 18 number fives. For fun, nope, it says 11 number fours. So for fun, let's move this. Let's move the, let's say that's the critical zone area right there. And 16 number fives there. Right there it says it. Down here it says 18 number fives. So across this driving parking area, they appear to want more steel across this area here. But we know that doesn't exist. We see two horns sticking out and that's it. And so therein lies your problem, the lack of steel in the stack. I think it's simple as that, is that they lack their steel. And now that you understand this, hopefully you understand critical zones and tributary zones. They need to marry each other. Is this married? It is not. It's outside the zone. Let's pull it down and make sure it's not married. It's outside the zone. We need this to marry into here. We need it so it stays flat. We don't want all that deflection there. Deflection equals strain equals pulling, and you get nothing for free, right? You get nothing for free. If you strain this down and deflect here, you're pulling on a steel, which is pulling on somewhere else, which is ultimately weakening your intercourse of your steel and your concrete. And the last thing you want is weak intercourse. You want some good intercourse between your steel and your concrete. You need some good intercourse between your male and your female for this to work out. You don't have good intercourse, you're just working on a bad marriage. All right. So I had, it's been a while since I brought that up. So I had to bring it back to life. All right. So now we're brought it back to life. This is the short version of it. Now my fancy version was, you can see they're all offset. When you lay out all these lines, when you lay out the lines, which I'm doing in a model, I'm still working on this model. It's a cardboard model. It's to scale. I'm still working on the model, and it's this zone here. You guys can beat me to it. Orion, you said you could help me out with some drafting. Well, this would drive you crazy, but maybe you could draft up something for me that would look like that, showing equal spacing. Anyone can do this, incidentally, with just a drawing program. You would just have to equally space these 14s, and then figure out where you're going to stop it. You're going to stop it midway between these two columns, or you're going to stop it over to here and have it overlapping. We don't know because they didn't take it apart forensically and look at it so we can see this bar stops here. This bar stops here. Clearly they could have done that. And literally, ironically, you would take it apart by layers, leave it where it is. When you get to that deck, you then jackhammer the deck apart right there. You first your laser, you use your sounding technology with it. Your sounding technology. You do some cores to try to figure out where it is, roughly. So you core the hell out of it. And then you start breaking it apart and letting the rebar talk to you about so you can actually see why you leave it there. And so you can find rust points. You can go, look here, really look this apart. Because it'll break apart pretty easily up to the rebar. And you break it apart and you go, look at this huge rust zone right here. But if you just grab the slab, drag it off somewhere else, and try to map it back together, you actually don't have the real location because parts of it are going to crumble, deteriorate. You won't get the mapping properly. you didn't do anything to maintain the continuity of that. So in other words, to do this, maybe you should get some zone over here while they're still on the ground. Get out there with a sprayer, literally, clean off the deck, power wash it off, clean a mess up, and then paint the damn deck over here. Paint it with some damn, pink and orange paint, run some stripes, right? So you run your stripes, and then you're now able to put the stripes back together in the somewhere else. But you had your location right here. If you wanted the people, you do a no-fly zone, you put the fence up around it, and you take your time and do this properly. But they already made their minds up. This is an exercise in academia at this point. It's an academic exercise, and that's about the size of it. Again, the BMA is what would have and the height elevation difference would have transferred this deck differently. I do think the other tower uses a higher deck, and then they transfer down into a lower deck here. So I do think the other tower might have a BMA in it across at the pool deck area. I only think that because I see a ramp down when you look at their structure from the street, and you look down and you zoom in. It appears to be a ramp down from the deck, being that this is higher than here. Even though this shows 1110 and it shows 1010, which would make this a step down into this deck. They actually have it so this deck is higher, and you ramp down into the lower deck. So I don't know if that's because they added a cover later on in tile and they changed the elevations. It could be something as simple as that they added all that tile work later. And it could be equal and no BMA present, as far as I know. All right, so there's your BMA right here, and there's one here. This would have helped. This could have helped with lateral shifting. This long BMA here definitely would have separated the structure and helped with lateral shifting. Here's a 1 foot 10 step here. This definitely would have boxed this area out. This 1 foot 10 right here would have definitely boxed this area out. Here's 1 foot. Delete. 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 Here's 1 foot 10 here. That's your box out. There's a BMA. So this all helps with that, with the movement. There's your BMA. So there's your BMA here. There is your construction joint here. I don't know if there was another one that was supposed to be here. That would have been a failure, a plane across there. Here's your very interesting, right? This is a BMA. So I'm going to go over this, and I've already had my answer, but I'm going to give you, so here's a breadcrumb. This BMA exists, right? So does this BMA. And you can go down here and say these exist also, right? The BMA is down here, and this one here. But more so, let's just stick with this zone here. This one exists, this one exists, this one exists. And yet we see a column collapse initially in the building construction, buckle, fail, and then we see the material stockpile down towards that direction. So that would be this column here, or this column. So I think this is L and that's M. So it's either L and M. So how do we get that? How do we get this one doing that? We need better video, but I want you to use that torque action, and after you run this steel in here, I want you to tell me how and remember this guy here shifts over and in. Over and in. So when you go in your parking garage, so this would be Jamie's challenge. Jamie, get into your parking garage. Oh, Ryan too. Oh, and Kent. This would be your challenge to tell me if this column right here, when you go into the parking garage, remember the lady comes down here and she sees the ramp. But at one point she turns around, spins around. Right here, she spins around. So ramp is ahead of me here. She talks about a parking garage. Okay. So challenge for Jamie, Ryan, Kent, and one other. I'm trying to think. She sees her. So here's our parking garage, our driveway here. Yep. So the driveway's here. So she sees her parking space, double columns, double columns, double columns, double columns, double columns right here. So she sees 17, I think, is right here, and right about here is that car. You can see the double columns together. That helps give you a reference. She's walking this way. She sees the BMAs above her head. To the right here, is there BMA going from here to here? Is there BMA going from here to this one column? Does it make it to the one column? We know it doesn't go all the way through. We don't see it there. We see just a short version of it. And then she sees this one from her vantage point over here. Does she see the little piece right here? The little section right here? Does she see it? Because I have you, remember, and I'm gonna, no, I don't want to cheat yet. But remember, this will be the one, you got a punching shear one here and here in our videos, right? So you got this one, and this one's up and out, pointing away from this direction here. And this is pulled in this direction. What does that tell you about this deck? What did it tell you about that? What this beam here did? It went above the deck and pushed down on the deck. If it pushed down on the deck, what did it do here? What did it do here? And why did it deflect? Why did it deflect to the right? Think about that. There's an image of it deflecting to the right. This one. Of all these punk shearing, why does this one deflect to the right? There's your tip. There's your huge hint there of its deflection. Let's see if I can show it to you in the image. There it goes there. So there's the structure they blew up. There is we're way up here of collapse, right? There's that guy there. And so take note what we have left. So did this one do any pushing down away from anything? But they'll get over it. They're going to beam to the right in a second. Okay, so this one is stable right there, straight. But yet we have one here that's down into, I guess, the right in this direction. I kept saying left. I didn't mean to get you on that one. They pulled it out already. With a saw. So do you see it right here? Beam, 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 BMH. So would you think that's a BMH, headroom up here? Would you think this is square in shape, presents square in shape? Would you think it's the other column? Where is the other? Remember one punch through the flower pot? I don't know if this is the one that punched through the flower pot and then they moved it around or not. Remember they destroyed it. And I understand one of you guys told me they have a cease and desist against the lady was doing because Surfside, her videos, they made her pull it down. And also we have an explosion at this point that did a lot of damage. So I'm not sure what we're looking at this point anymore for data-wise. We need to go back to the original images. All right, ending video, but I wanted to give a shout out to my girl over there is, sorry, I don't remember girls like that. Too many of you. 2 girls. Yep, 2 girls. So, and anybody else who did it before 2 girls or during, that was back here where I still got to prove it still. So I want you to see the tributary areas here. and why I did that fancy thing saying, well, wait a minute, if they're crossing each other, we just need to get it over here. It can be on a diagonal to get it over there. So why can't it be? So as long as the steel is being stressed and transferring the loads back to the critical area, why can't it be on a diagonal? Of course it can be on a diagonal. They make diagonal, you're doing a punching shear, you put it on a diagonal all the time. So that engineer from Europe, it says that, oh, you're just full of it. Hey, dude, go back to school, read a book. I'm sorry, go back to school for 5 years or read a book. A book, single book, same answer. Puncturing works as Gregory showed us in the flooring also. And if you guys spend some time with looking at puncturing designs, you'll see that they are on 45s and angles. I pass on that. Easy pass. So the, oops, looks like an easy answer. Hello. Looks like I didn't answer. So much for that. Okay. I don't know why I did that just now. I just messed up my screen here. That's something new for me, how it separated. That was weird. All right, there we go. Grab from the corner. So now you understand your tributary areas are between your critical areas. Your critical areas are the ones that will take the loads of the tributary areas so it doesn't punch through around the columns. With that said, now you have enough information to start looking at each column and tell me what each column, how it failed. You say, oh, tributary area. Oh, this one over here is a critical area failure. Column bent over on this one, so we have some. This obviously stayed together to be able to be pulled over, or pushed, and that's my trick to you, and I'll give it away. I'll give this away to Jamie or whoever you guys want to tell me. Tell me what happened to that column, this one here, the one that's in the images. Go find the images and tell me whether it was pulled or pushed over. Pulled or pushed. Which one was it? Pulled or pushed? I can't remember the photographs. I told you I got to answer these people. Yep, I got to come up with something creative for you two girls. You're outdoing me right now. So pulled or pushed. Which one is it? Was it fractured at the bottom? And there's your research you can have if you care about inelastic loads. Elastic returns, inelastic does not. Rebar is, for the most part, inside the. Okay, so I'll end it with some sexual courses here, marriage courses. So rebar is a one-off deal. Once it's had, it may like the intercourse between the male and female. The male may like the intercourse in with the female, but once it has lost its interaction, it's lost its interaction. It's done. It's one and done. So you get the remit one time, and then you're done. You're done until you use some epoxy on the man. He's done. He's done. It's useless. It's lost its size. It's not big enough anymore. Wow, that is something else. Yep, that would be one of my worst ones. Bye.